Hello, in this video I am just going over conductors, um, not just conductors, but anything that can carry charge. So I'm going to go over the basic definition of conductor, a superconductor, semiconductor, and insulator. Okay, and conductors are basically like, here this is a golden wire or silver wire and it keeps going along. A conductor is just that there will be electrons in here flowing this way. And that's all it is. It has relatively low resistance, except for over long distances. Um, so, for example, if a copper wire is 1 meter long, it'll probably have a resistance of 0.5 ohms or something like that. Don't quote me on that. I'm just giving an example. The next would be a insulator. So say we have this insulating wire right here, and it is 1 meter. In here, electrons tend to get not moving in a they don't move just in a straight line. They end up bouncing off of a lot of other atoms, or at least they interact with each other more. So they'll be all over the place. So they'll kind of bounce around. And for like 1 meter, again, I don't know. I'm not using a specific material here. It might be 100 ohms of resistance. Um, so this would be a insulator. This would be a conductor. And then we have the next type, which will be a semiconductor. And the semiconductor is right here. And they are things such as water. So if this was a tube of water or some, well, similar material, it would be like this. And say we have, some electrons moving. For 1 meter, we might have something like 20 ohms of resistance. And yeah, this would be something like water. Like if you picture you dropping a flashlight into the ocean, it doesn't travel very far compared to if you dropped like some electrical charge into a conductor, pretend it's a liquid, it'd travel throughout that entire liquid in all likelihood. An insulator, it wouldn't travel at all. The last we have, I don't know if you can see this, is a superconductor. And superconductors have interesting properties, and they'll probably become a little bit more commonplace if people can figure out how to use them properly at room temperature. And essentially what they are materials which at low temperatures right now, or maybe probably less than 25 Kelvin, they have a resistance of 1 meter equal to 0 ohms. And they think that happens because, say, we have a bunch of atoms right here. Here's an atom, here's an atom. They think at the cold temperatures, they stop vibrating enough and slow down enough that there's relatively no resistance for these electrons to pass through. So instead of up here where they bounce off the different objects, like over here, it'll, go up here, then be like, oh no, just go like that, kind of. Meaning there'll be some resistance, some energy loss due to that, and, say it runs into one, it bounces up over here, and then bounces back down, stuff like that. So that's the reason they believe semiconductors work. I think in like the early 90s, They created semiconductors which can work at slightly higher temperatures because it was around 5 Kelvin or lower. Now I think it might be up to 20 Kelvin. That's still negative 100 over 100 degrees Celsius, so no one's going to find it in their regular home. But they're trying to work out stuff like that. Anyways, I hope that gives you a quick explanation of what these different terms mean, and I will have more videos out shortly.